So this example serves two purposes: more practice on dealing with the impulse calculations, and also to illustrate something that's taught by every sports coach in which you hit a ball, and that's about follow-through. But we'll get to the follow-through section in a bit. Right now we'll just deal with the impulse. So what we have is a 57-gram tennis ball. Now, before I move on off of that, anytime we do calculation, we do need mass in kilograms, and because there's 1,000 grams in 1 kilogram, we'll divide by 1,000 and get 0.057 kgs as the mass. Tennis ball is thrown upward, then struck just as it comes to rest at the top of its motion. The racket exerts an average horizontal force of 420 newtons on the tennis ball. A, determine the speed of the ball, which would be V. After the collision, if the average force is exerted on the ball for 4.5 milliseconds. That would be the time. And again, like with the last example, time and calculations must be in seconds. So 1,000 milliseconds in 1 second, 0.0045 seconds. Now this is a place where using delta P equals F delta T is not the best option for the impulse. This would be the place where MV equals F delta T is more useful, since we do have mass and the speed is what we're trying to find. So substituting in what we know, mass 0.057 kg, V we don't know, F 420 newtons, delta T 0.0045 seconds. Multiply out the right side. We get 1.9. Divide both sides by 0.057. Going to 2 sig figs, as we have with everything, we get 33, and speed is measured in meters per second. So questions B and C here. B is very similar to A. Now we're just going to assume a time interval of 5.3 milliseconds. So we'll go and we'll just put into the equation. No need to define the variable since they're exactly the same. So 0.057 V equals 420. And we do need to convert the milliseconds to seconds, so divide it by 1,000, 0.00053. Multiply out to the right side. We get 2.2. Divide both sides by 0.057. And we get a speed this time of 38 meters per second. So this is where we'll pull in that concept of follow-through on hitting a ball. What follow-through means is you actually carry the tennis racket, the bat, the hockey stick, the whatever you're using, and you carry it and you try to keep it in contact with the ball as long as possible. Now, we're only going from 4.5 milliseconds to 5.3 milliseconds, but we can see there is a clear difference. The speed with a 4.5 millisecond hit is 33 meters per second, and with a 5.3 millisecond hit is 38 meters per second. So what does follow through do? I will try to write this as nicely as possible. Follow through keeps contact for longer, and that's the key thing with this. We have a longer contact. What it does, it allows the applied force to act for longer, and the consequence of that it increases the final momentum of the ball. So to any of you who play sports or have played sports, and the coach always says you have to follow through, this is why. It allows the ball, or I guess hockey allows the puck, allows whatever you're hitting to move faster. So yes, those coaches were right. You do need to follow through as much as possible. And this is a scientific explanation of why.